Hello everyone. The title of this video is Graph Inequalities on the number line, right, the real number line, and it's going to be many examples. And what I'm going to be doing is I'm going to be kind of just making putting together kind of like a solutions manual for the openstacks.org Intermediate Algebra 2nd edition textbook. So here I am on the section 2.5 of, again, you look at the openstacks.org, their Intermediate Algebra 2nd edition. And I'm just going to be going in all these videos, my OpenStax videos. Just going to be taking you through some of the exercises at the back of the section. Right? So here's section 2.5 exercises. And the first heading, the first exercises are graph inequalities on the number line. So yeah. And these are actually pretty nice, this OpenStax. You know, some of these already have solutions that you can look at. If you just simply go to the number, click on the number, there's a link that takes you to the page with the solutions. Actually do it here. It takes you to the answer key, eventually down to that exercise. Just give it a second here. There we go. And you can see the answers to exercise 2.5, number 297 there. And then you click on number 297 and it takes you right back. Eventually. Alright, give it a little time. So it's back in section 2.5 and should take me right back to exercise 297. If not, I'll pause it and fly there in a second. Alright, here we go. Alright. So that's how you can navigate this pretty easily. Go to the, now again, that's only for like certain odd numbered problems. I'm going to work on all of them though. And I would recommend that when I start working on a problem in the video, maybe pause it. My hope is that you've read the section and understand a little bit what's going on. You took some notes, possibly watched some other people's videos related to it. I don't know what you've done exactly. I'm just hoping that you studied a little bit, at least read through the section. And when you see me start an example in the video, pause it. Maybe try to do it yourself first, and then watch me do it and see how our methods compare. Okay. Alright, so I'm starting here on number 296. Now I'm not calling it number 296. I'm just doing example 1 through 20. I think there are 24 of these where we're graphing inequalities. Alright, so let's get to it. Alright, so the first example, again, in each of these I'm asked to graph the inequality on a number line and write in interval notation as well. Alright, so anytime you see the word graph, right, that just means draw a picture. Draw a picture of the solutions of the equation or the inequality you're looking at. And so here we have, now in all the examples, in all the exercises, the variable that's in question is the variable x. Please know that, in other textbooks, in other sections, the variable is not always going to be x. Right, but here the variable's x, and our first example is that x is less than negative 2. So I'm going to draw a number line. Right, just some horizontal line. I'll put little arrows on the ends. And I'll say this represents, possible values of x. Maybe I'll call this like the x-axis, x number line. And number line works like this. So you got 0 in the middle, positive numbers going to the right, so there's positive 1, positive 2, positive 3, etc. And in between there's fractions and decimals. There's a half there, and 1.5, 2.5, and pi 3.14159, so on would be here between 3 and 4. Every single point on the line represents a number. And that's going to the right, the positives. And then going to the left are the negatives, negative 1, negative 2, negative 3, negative 4, and so on. And one thing to point out here is that if one number is to the left of another number, the number on the left is considered the smaller number, and the number on the right is considered the larger number. So we're asked here to make a graph of all the numbers, all the values of x that are less than negative 2. Alright, so first I'll point out, where negative 2 is. Alright, that's right here. There's negative 2. And then all the numbers less than negative 2, right, that I could replace x with and satisfy this inequality are these numbers, negative 3. Right, negative 3 is less than negative 2 is to the left. Negative 4 is less than negative 2 is to the left. Negative 2.1 is less than negative 2 is to the left. In fact, all the numbers, to the left. So I'll mark that off here. And going on forever. All these numbers are solutions. Right, they satisfy the inequality. Now what about negative 2 itself? Well, negative 2 is not to the left of negative 2. Negative 2 is equal to negative 2, not less than negative 2. So to indicate this, I note where my arrows go in here, all the solutions are, and then to indicate that negative 2 itself is not a solution, in this particular text they're using a parenthesis, right, a curly parenthesis, opening in the direction of the solutions. But if you see a parenthesis, right, left parenthesis or right parenthesis on a number, that implies that the number below it is not a solution. Okay, so negative 2 is not a solution, but all the numbers I've indicated otherwise are solutions. Alright, now in other cases you'll see these brackets, rectangular brackets, a left rectangular bracket or a right rectangular bracket. If you see that symbol written above a number, that means that that number is a solution. It does satisfy the inequality. All right, and then that leads me to what they call interval notation. So here's a graph, right, a picture of the solutions, and then we're describing the solutions in this interval notation. Now in this picture, and in every picture in this video, there's only going to be one interval, one piece of the graph. In the future, you may see graphs that are broken up into multiple pieces, so we'll be writing multiple intervals. But for right now, we have just this one piece of solutions here, this one arrow to the left here of negative 2. Always write your intervals from low to high. Always write intervals from low to high. Okay, left to right on the horizontal number line anyway. Alright, so what you do is you first put, in this interval, in this set of solutions here, what is the lowest number in this set? Well, there is no lowest number. It's going to the left forever. Negative a million is less than negative 2. Negative a billion, negative trillion. So there is no lowest number. So we're going to indicate that with negative infinity. All right. So negative infinity will be the symbol used to indicate that there is no lowest solution. It just goes to our solution set goes to the left forever. So there's no lowest solution. So I put the lowest solution, the lowest number in the interval, then a comma, and then I put the highest number, or at least where do I exit as I go from left to right? Where do I exit this set of solutions? Well, I exit at negative 2. Right. Now I know negative 2 is not a solution, as we've said, but it is where this picture of the solution stops. Right? So where does it start on the left? Well, there is no start, so there is no lowest solution. I put negative infinity. And then whereas I go from left to right, where does it stop? It stops at -2, so I put lowest, comma, highest. Right? All right, then on the ends, you are going to cap it off with either parentheses or brackets like I have written here, like you're going to see in the graphs. I'll tell you this right now, negative infinity and alternatively positive infinity are not numbers. They're concepts. Negative infinity is not a number. I can't plug it into my variable. So you always cap parenthesis, negative infinity or positive infinity with parentheses. Right? And that's another note I'll leave. So you always parentheses on infinity or negative infinity. Right? Always parentheses on your infinity symbols. And then on the other end of this interval, this piece of the picture, the question is again now, is -2 a solution? No. -2 is not a solution. I mentioned that earlier. So again, I cap with parentheses. If it were a solution, I'd cap it with one of the rectangular brackets. All right, so here is the interval notation for our graph, for our inequality. And all three of these things mean the same thing. They're describing the same numbers. This is what are all the numbers less than -2. Here's a picture of all the numbers, where all the numbers are on the number line that are less than -2. And here's another description of all the numbers that are less than -2, right? From negative infinity, to the left forever, up to -2, but not including -2, thus the parentheses. All right, so I took this first example quite slowly. I'm going to do the first three of these pretty slowly, and then I'm going to kind of go a little faster for the rest of them. All right, and I'll also have the video broken up. If you look into the description of the video, I'll have timestamps for when one example starts, or for when each example starts, so you can just go from one example to the next without having to watch all of them if you wish. All right, so here's another one. Same instructions, right? Graph the inequality on a number line. So let me draw a nice, again, I'll do a horizontal number line again. I'll just pop up here 0. And this is looking for what are all the numbers that I can replace x with that are greater than -3.5 or equal to, right? Remember this symbol with the little half equal sign underneath is greater than or equal to. All right, so first off, where is -3.5? Well, here's, -1, -2, -3, -4, and then -3.5 would be, halfway between -3 and -4. So there's -3.5. And I'm, trying to find all the numbers, point out all the numbers that are greater than -3.5. So that would be all the numbers to the right. Right? Any number to the right of a number is greater. So -3 is greater, -2 is greater, -1 is greater than -3.5, and so on. So I indicate that with this arrow. But what about -3.5 itself? Now -3.5 is not greater than -3.5, but it is equal. They are the same number. So this time, instead of parentheses, I'm going to put that rectangular bracket. Now in some other books you might just see a closed point, but in this particular OpenStax book I'm looking at, they indicate that a number is a solution by putting this rectangular bracket over it. Great, and here's a picture of all the solutions, all the numbers that satisfy that inequality, that if I replaced x with any of these numbers, this would be a true statement. All right, then our interval notation. Again, always going low to high, left to right. So going left to right, this interval, this piece, this picture of solutions here starts at negative 3.5. So I put that first, comma, and then this piece of solutions never ends, right? As I go left to right, it goes on forever. 1,000, 1,000,000, 1,000,000,000, right? Those are all solutions. So to indicate that it goes on forever to the right, I'm putting just positive infinity, right? Or just the infinity symbol. All right, so I have my left end of the interval, the right end of the interval. There is no right end. And then I cap them off with parentheses or brackets. Well, as I said before, negative 3.5 is a solution. So on this negative 3.5 in the interval notation, I cap it with a rectangular bracket. Right? And be careful when drawing these. If you rush it, if you do it too quickly, it'll look like a parenthesis, and then you'll be marked off. Right? So try to draw nice corners here, right? 90-degree angles. And then, as I mentioned in the previous example, infinity is not a number. Same with negative infinity. So always cap off the infinities with parentheses, because something that's not a number can't be a solution of anything. Okay, again, very simple as that. All right, now I'm going to start going a little faster. So here's another one, number 3. X is less than or equal to 2/3. So again, I'm looking for all the numbers that are less than 2/3, so to the left of 2/3 on the number line, and also equal to 2/3, so 2/3 itself. So again, here's number line. There's 0. Now 2/3, let's say that's the number 1 there. 2/3 is, between 0 and 1. It's 2/3 of the way between from 0 to 1. So there's 2/3. And all my solutions are the numbers less than 2/3, right? All the numbers to the left of 2/3. So I indicate that with that arrow there. And equal, or equal to 2/3. So 2/3 itself, meaning I'm putting this rectangular bracket above 2/3. And then the interval. I'm just going to put INT for interval from here on out, right? Interval. Left to right. What's the left end of this, this picture of the solutions? There is no left end. So again, as I did in the first example, I indicate that with negative infinity. And where does this piece of solutions end? It ends at positive 2/3. Negative infinity, always capped with parentheses. And then 2/3 is a solution. So I cap it with the rectangular bracket like in my graph. And again, all 3 of these things are describing the same set of numbers, all the numbers left of 2/3 and including 2/3 on the number line. All right, so after those first 3, you see how quick this can be, especially if the variable's on the left side like this and already alone. These can be very quick to do. So on my next pages, I have four problems on each page that we'll just kind of fly through. So number 4, and I'm drawing a number line. Here's 0. I'm looking for all the numbers greater than 3. So here's 3, right? Let's say this is 3 here, 1, 2, 3. All the numbers greater than 3 are the numbers to the right of 3. So I'll indicate that with this arrow here, 4, 5, 6, 7, 8, and so on. But, just greater than 3, not equal to 3. So 3 is not included, meaning I'm putting a parenthesis over the number 3. And then for the interval, in left to right always, this picture of the solution starts at 3 and then doesn't end. So it goes to positive infinity. And 3 is not a solution, so I cap it with parentheses. Infinity is not a solution. Infinity is not a number, so I cap that always with parentheses as well. And there, I'm done with that one. Number 5, another number line. Here's 0. And I'm looking for all the numbers x, all the numbers I could replace x with that are less than negative 1/2, right, negative 0.5, or equal, right, less than or equal to negative 0.5. All right, so here's, let's say that's negative 1, and negative 0.5 would be halfway between negative 1 and 0. So there's negative 0.5. All the numbers less than negative 0.5 are to the left of it. So all these numbers I just indicated. Or equal. So negative 0.5 is included, meaning I put one of these rectangular brackets. And you might be noticing that when I draw the parentheses or the brackets, they're always opening in the direction of the other solutions. All right, and then my interval. Again, left to right, there is no far left, so negative infinity. And it ends at negative 0.5, parentheses on the negative infinity, bracket, right, rectangular bracket on the negative 0.5. Simple as that, right, because it is a solution. All right, number 6 here, x is greater than or equal to, again, 1/3, positive 1/3. So here's a number line, there's 0, there's 1, so a third, right, would be here, a third of the way between 0 and 1. I'm looking for all the numbers greater than a third, so those would be the numbers to the right of 1/3, and all the numbers greater than or equal to 1/3. So again, the bracket on 1/3, meaning that 1/3 is also a solution. Then the interval, left to right, starts at this piece of solutions, starts at 1/3, so I write 1/3, doesn't end, right, so it goes to infinity. 1/3 is a solution, so rectangular bracket. Infinity is not a solution, parentheses. Right, all the numbers greater than 1/3 or equal to 1/3. Number 7, x is greater than or equal to negative 4. Number line, here's 0. Now after a while you just start going, hey, negative 4 is going to be over here somewhere, right? Just make sure it's left of 0, and I'm looking for all the numbers that are greater than negative 4. So that would be the numbers to the right, or equal to negative 4. So again, negative 4 is a solution. Have a rectangular bracket above negative 4. And then the interval, always left to right, low to high. This piece of solution starts at negative 4, and it never ends, so it goes to a positive infinity. And then negative 4 is a solution, so bracket on that end of the interval. And infinity is not a number, so not a solution, parentheses on infinity. Okay, and hopefully after these, you're seeing how very, very quick these can be. Okay, so number 8. X is less than 2.5. The number line 0, 2.5, that's positive, so that'd be to the right of 0 here. All the numbers less than 2.5 are to the left. But 2.5 itself is not less than 2.5, and you don't have the or equals here, it's just less than, so I got a parenthesis above 2.5. And then the interval, left to right, there is no left end to this piece of solution, so negative infinity up to, and then it ends at 2.5, and parentheses on both of these, right, because neither one of them is a solution of the inequality. This one, number 9, x is greater than negative 3/2. That's negative 1.5. Again, just after a while, you're probably going to be like, negative 1.5. You don't have to put it down all the integers. Just say, hey, that's going to be here, somewhere to the left of 0. So say there's negative 3/2. And we're looking for the numbers that are greater than negative 3/2. That would be the numbers to the right of negative 3/2. But not equal, right? So again, parenthesis on negative 3/2. And when I'm drawing the interval, from left to right, this piece of solution starts at negative 3/2. It never ends, so negative 3/2 to infinity. And negative 3/2 is not a solution, infinity is not a solution. I put parentheses on both those. And there's my interval notation. Okay, very quick and easy, right? Number 10, number line. Here's 0. We're looking for all the numbers less than positive 5. So that would be over here to the right of 0. So I just mark off where 5 is somewhere to the right of 0. And all the numbers less than 5 are to the left, right? 4, 3, 2, 1, 0, all the negatives, all these numbers here, or equal to 5, right? So 5 is a solution, right? 5 is equal to 5, so you got the rectangular bracket. Simple as that, simple graph. Then for the interval notation, left to right, there is no left end, so that piece is starting at negative infinity, and this piece of solutions ends at positive 5. Negative infinity is not a number, so again, parentheses on that. 5 is a solution, so brackets on that, and there's the interval notation for that graph, for that inequality. All right, now I've just got two more of these, and then we got some examples where we have what are called compound inequalities, so it'll start getting a little more interesting. All right, so here we have x is greater than or equal to negative 1.5. So again, say here's 0. This is negative 1.5. And that'd be over here, right? Negative 1.5. In fact, that's the same as negative 3 halves, isn't it? And we're looking for all the numbers x that are greater than negative 1.5. So that'd be the numbers to the right. Right? 0, 1, 2, 3, etc. Negative 1. All the numbers to the right are greater. Or equal. So this time, negative 1.5 is included in the solution set. So I put the rectangular bracket. And then interval notation, this piece of solutions starts on the left at negative 1.5, put a comma, it never ends, so it goes to infinity. Negative 1.5 is a solution, so bracket, and infinity is not a solution, right, so parentheses. All right, number 12, example 12. Same instructions, still a simple inequality, right? X is less than negative 7/3 or negative 2 1/3. So there's a number line, there's 0, and this is going to be over here somewhere, right? Because it's negative. And we're simply looking for all the numbers less than negative 2 1/3, negative 7/3. That's the numbers to the left. So I indicate it with an arrow like this, and less than but not equal. Right, so negative 7/3 is not a solution, so I put parenthesis above negative 7/3. Then for the interval, right, this piece of solutions, the far left, there is no left end, so I put negative infinity. Up until negative 7/3 is where it ends. Always parentheses on infinities. And negative 7/3 we said was not a solution, so parentheses on that, and there's your interval notation. All right, finally we're getting into something interesting. So example 13. See how I have negative 5 is less than x, and at the same time x is less than 2. This is two inequalities written as a single inequality. Another name for that, two inequalities combined to make a single inequality, is a compound, right? A compound inequality. Right. Now all the compound inequalities in this video are going to be of this type, where you have the variable alone in the middle in between the inequality symbols, and then some numbers on the outside. And these inequalities are AND inequalities. You also have compound inequalities that are OR inequalities. You have the word AND versus the word OR. These are AND inequalities. This is negative 5 is less than x, and at the same time x is less than 2. So we're looking for numbers x such that negative 5 is less than those numbers, or those numbers are greater than negative 5 if you read it from right to left. And at the same time, those same numbers, those x's that we're looking for, are less than 2. So here's a number line. Okay, let's say there's 0, and the numbers that show up here are -5, which would be to the left of 0, and +2, which would be to the right of 0. Right? And like I said, we're looking for all the numbers that are greater than -5, right? So to the right of -5, but at the same time less than 2. So to the right of -5, but at the same time to the left of 2. Well, the only numbers that satisfy both of those are the numbers in between. And no arrows, notice, just the numbers in between. These are the solutions of this compound inequality. They make this a true statement. Right? Something past 2 can't be it. 3, like 3 for instance, right? 3 is not less than 2. You have to satisfy both in order to be part of the picture. You know, -6 is not greater than -5. So again, you have to satisfy both. And the only numbers that do that are the numbers in between -5 and 2. All right, well, what about -5 itself? Well, -5 is less than 2, sure. But it's not greater than -5, it's equal. So -5 doesn't satisfy both. So it's not a solution of the compound inequality, meaning I'm putting a parenthesis symbol above it. Same thing goes for 2. You know, 2 is greater than -5, cool. But it's not less than 2. So the number 2 itself doesn't satisfy both. So it would not be a solution. And I put parenthesis above 2 as well. So the only solutions are the numbers between -5 and 2, but not including -5 nor 2. And then when we do interval notation, same thing. This is another picture with just one piece of solutions, one interval. And I'm writing it from low to high, left to right. This begins at -5, so I write -5, and then as I go from left to right, it ends at +2. So I have -5, comma 2, and then I cap it. -5 is not a solution, right? Doesn't satisfy both inequalities, so parenthesis. And 2 is not a solution, because it doesn't satisfy both inequalities at the same time, right? Just one of them. So parentheses on that. And there's the interval notation for this picture of solutions to this compound inequality. All right, and again, once you get one of these down, the rest of them should be pretty simple. So there's another one, number 14. This is saying that I'm looking for numbers that are greater than or equal to -3, if you read it from right to left. Numbers that are greater than or equal to -3 and at the same time less than 1. So this is just simply between -3 and +1. All right, just like up here, these were the numbers between -5 and 2. This is representing the numbers between -3 and +1. All right, now what about -3? Well, -3, notice there's the or equal to sign here. -3 is greater than or equal to -3. That is true. And at the same time, -3 is less than 1. So I got a bracket on -3. -3 is a solution to this inequality. -3 does satisfy both of them. But 1 does not. The other end, 1 is greater than or equal to -3, sure. But 1 is not less than 1. 1 is equal to 1. And you may have guessed this by now, but when you see less than or equal to or greater than or equal to symbols, you're getting brackets, rectangular brackets. When you see just less than or just greater than symbols, you're getting parentheses. Like I said, you probably have noticed this already. All right, there's a graph then, a picture of the solutions that make, the numbers that I can replace x with to make this true. And then the interval notation, same deal. There's only one picture of solutions here, one piece, one interval. left to right, it starts at -3, it ends at +1. -3 is a solution, so the rectangular bracket on -3. 1 is not a solution, so parenthesis on that. And notice how this one, you have 2, is less than or equal to is less than or equal to. So here's 0, +1.5 is here, and we're looking for the numbers that are greater than or equal to 0 and at the same time less than or equal to 1.5. Well, that's all the numbers in between 0 and 1.5, right? Those are the numbers that satisfy both, including both 0 and 1.5, right? 0 satisfies both. It's greater than or equal to 0 and less than 1.5. And 1.5 satisfies both as well. Right, so I got bracket on the 0, bracket on the 1.5. And then interval notation, right? This piece of solution starts at 0, going left to right, ends at 1.5. And then you have the rectangular brackets on both ends. Both 0 and 1.5 are solutions. All right, and this is pretty much what I have for the rest of the examples. So these should be relatively quick. So yeah, all these same looking compound inequalities. All right, so again, number line, -2 and 0 are mentioned. -2 should be to the left of 0. And what we're asked to find in this one are the numbers x that are between -2 and 0, but notice that these are both is less than, or is greater than if you're reading them the other way. But not equal to, right? So -2 is not a solution to both. It doesn't satisfy this compound inequality. Same thing with 0. 0 doesn't satisfy both. Yeah, 0 is greater than -2, but it's not less than 0. So neither one of these ends, -2 or 0, nor 0, are solutions. And then for the interval, right, begin left end -2, right end at 0, and parentheses on both because neither one are solutions. Really can be as quick as that. Example 17. Let's put 0 over here. We got -5 and -3 are mentioned, right? So and -5 should be to the left of -3. And we're looking for all the numbers that are greater than or equal to -5 and at the same time less than -3. Well, again, all the numbers in between them would be good. And then you got the greater than or equal to -5. So -5 will satisfy both, but only x less than -3, so not equal to -3. So -3 does not satisfy both. So bracket on -5, parenthesis on -3. And then for the interval, right, left to right, low to high, begins at -5, ends at -3, bracket on the -5, parenthesis on the -3. Just like in the graph. Very, very simple. All right. The next one, number line. The numbers mentioned are 0 and +3.5. Again, it's one of those compound inequalities where our numbers we're looking for are between 0 and 3.5. And including both. You have the or equal to on both of these. So 0 is a solution, satisfies both. 3.5 would also satisfy both. Right, and then for the interval, this piece starts at 0, left to right goes to 3.5, and then you have the rectangular bracket on both of those. Number 19. -1 is mentioned. Let's put that here. 3 is mentioned. That would be to the right of -1. Just make sure the numbers are in the correct places. Don't put negatives to the right of positives. And it's one of those compound inequalities again where I'm looking for the numbers that are greater than -1 but at the same time less than 3. That's all the numbers in between. And this time they're both just is less than. So -1 is not a solution. +3 is not a solution to this compound inequality. Then the interval, going from -1 to +3, parentheses on both. Right? Neither one of those is a solution. All right, just got a few more. All pretty much the same. Right, so again, if you're happy with what you've seen so far, you can obviously stop it. All the rest of these are pretty much the same thing. So this is another compound inequality. We're looking for the numbers greater than -3 and at the same time less than or equal to -2. So -3 is mentioned. -2 is mentioned. That would be to the right of -3. And we have all the numbers in between those are good. Not including -3, but including -2. Right, so parenthesis on -3, bracket on -2. And then for the interval, right, we're going from -3 to -2 as we go from left to right. Parentheses on -3, rectangular bracket on -2. All right, here we got, for, -1.25 is less than or equal to x, and x is less than or equal to 0. All right, so the numbers x here, there's -1.25, 0 would be to the right of that. And all the solutions, all the numbers that satisfy this compound inequality are between -1.25 and 0, also including -1.25 and 0. Right? You got the or equal to. So brackets on both of those. And then for the interval, -1.25 to 0, brackets on both. Number 22 here, -4 is mentioned, +2 is mentioned, would be to the right of -4, and all the numbers that satisfy this compound inequality would be the numbers between -4 and +2, but not including either one of those ends, right? -4 would not be a solution, +2 would not be a solution, because it doesn't satisfy both inequalities. And then the interval, right, you have -4, left to right, -4 to 2, parentheses on both. Very, very, very simple. All right, I've got just 2 more of these, and then we're done with the OpenStax exercises on this topic. Same looking stuff. Here's -5 mentioned here. -2 would be to the right of -5. All the solutions of this inequality are between -5 and -2, not including -5, so parentheses on that, but including -2, so bracket on that. And then the interval notation, we're going from -5 to -2 as you go left to right, parentheses on -5, bracket on -2. And finally, the last of the exercises from the OpenStax book on this pretty simple topic. Number line, here's -3.75, 0 would be to the right of that. And all the numbers that satisfy that I can replace x with that make this compound inequality a true statement are the numbers between -3.75 and 0, and then including both of them. You got less than or equal to, less than or equal to. So -3.75 would be satisfying both, and 0 would be satisfying both. And then for the interval notation, right, this piece goes from -3.75 to 0, so I put -3.75 comma 0. And both of those end numbers are solutions of the inequality, so I put the brackets. Wonderful. All right, so hopefully watching me go through those, practicing them on your own maybe, help you out when you're working on similar problems. And thank you very much for watching.